Hi everyone, what's up? Welcome back to my tutorial channel. It's Daniela Tran here, and today we are going to continue to work on section 6.2, the advanced level from the IFM practice problems. First, problem 1. The current spot price of a raised element PP is 500 per ounce. The 9-month forward price of 1 ounce is 511.92. Today Albert enters into the short sale of 3,000 9-month forward contracts of PB. At the end of 9 months, he has realized a profit of 31,000 for 1,592 cents. Determine the price of 1 ounce of BB at the end of 9 months. So here he sells 3,000 contracts of PP, and the profit is 31,415.92 cents. So we first have to find the profit per unit. So the profit on one contract is 31,415.92 over 3,000, which is equal to 10.47. So Albert has $10.47 for one contract. Now for each contract, we got the forward price is 511. And of course, in order to have positive profit, the price of a contract at the end of 9 months should be less than the forward price. So the price of one share of PB at the end of 9 months is 511.92, subtract 10.47, which is 501.45. So the answer is $501.45. Problem 2. A certain stock pays dividends continuously at the rate of delta per year. The current price of the stock is S. If the continuously compounded risk-free interest rate is 6%, then the 2-year forward price of the stock is 135.80293. If the continuously compounded risk-free interest rate is 10%, then the 1-year forward price of the stock is 134.76665. Determine delta. So this is a circumstance of forward contract with continuous dividend. The formula to calculate the forward price of the stock with continuous dividend is F0t is equal to S0e to the R minus delta times T. Here F0t is the forward price, S0 is the current price, R is the risk-free interest rate continuously, and delta is the dividend continuous rate. T is the duration. Now let's apply to the first situation where we got R is 6%, T is 2, and F is 135.802.93. We got 135.802.93 is equal to S0e to the 0.06 minus delta times 2. And similar for the second situation, we got 134.76665 is equal to S0e to the 0.1 minus delta. From these two equations, we see there are two variables, S0 and delta. These are not given. But we don't want to care about S0, so we'll find a way to eliminate it. And the best way to eliminate S0 here is just divide side by side. So we got the ratio 135.80293 over 134.76665 is equal to e to the 0.02 minus delta. We just have to divide side by side, and S0 with S0 will automatically cancel. Now from here we have an equation of delta. So delta here should be 1.234%. So the answer is 1.234%. Problem 3. The current price of a medical company stock is 75. The expected value of the stock price in 3 years is 90 per share. The stock pays no dividends. You are also given the risk-free interest rate is positive. There are no transaction costs. Investor require compensation for risk. The 3-year forward price on a share of the stock is X, and at this price, an investor is willing to enter into the forward. Determine what can be concluded about X. So basically, we have to say something about X here, and to be more specific, we have to compare X to 75 and 90. So let's write out a formula for everything. First, 75 is just S0, right? And X here is the forward price, the 3-year forward price. So X is equal to F03, and it is equal to S0e to the 3R. R here is the risk-free interest rate, and since R is positive, so of course we got X to be greater than 75. And now let's consider the number 90. 90 is expected value of the stock price in 3 years. So 90 is expected value of S3, and it is equal to S0e to the 3 alpha instead of R. Alpha. It is equal to 75 e to the 3 alpha, and this is greater than 75 e to the 3R in this problem. And it's of course 90 is greater than X. The explanation for alpha is greater than R is like the investor are risk averse, means they prefer to take risk to not take risk if the average rate of return is the same. So basically, they need to receive on the average a rate of return than the risk-free interest rate on the shares they invest in the stock. That's why alpha should be greater than R. So it's like R is the interest rate that they pay if in case they borrow money. R is the interest rate from the market. So in order to have profit, they have to make sure their return rate should be greater than the risk-free rate. That's why alpha should be greater than R. It's right at the third information. Investor require compensation for risk. So eventually we got X is greater than 75 and 90 is greater than X. So we got X to be in between 75 and 90. Problem 4. A certain stock costs 40 today and will pay an annual dividend of 6 for the next 4 years. An investor wishes to purchase a 4-year prepay forward contract for the stock. The first dividend will be paid on 1 year from now, and the last dividend will be paid just prior to delivery of the stock. Assume an annual effective interest rate of 5%. Calculate the price of the prepaid forward contract. So here we got the cost of the stock today is 40, which means S0 is 40. And we have discrete dividends. So this is a case of prepaid forward with discrete dividends. And we want to find the price of the prepaid forward contract. So let's write out the formula of the 4-year prepaid forward contract. We got F04P, which means the prepaid forward contract price during 4 years. This should be equal to S0 minus the present value of the dividend, because we are considered at time 0. F04P here is the prepaid forward contract price. It is calculated at time 0. S0 is the current stock price, which is also calculated at time 0. But the dividends are at time 1, 2, 3, and 4. So in order to bring them to time 0, we have to find their present value. So now S0 is given, which is 40. And the dividend, we got 4 dividends at the end of each year, from the end of first year to the end of 4 years. So we got the present value of the first dividend is 6 over 1.05. The present value of the second dividend is 6 over 1.05 squared. The third one is 6 over 1.05 cubed, and the last one is 6 over 1.05 to the 4. And from here, we got is 18.72. That is the price of the prepaid forward contract. Answer 18.72. Problem 5. A market maker in stock index forward contracts observes a 6-month forward price of 112 on the index. The index spot price is 110 and the continuously compounded dividend yield on the index is 2%. The continuously compounded risk-free interest rate is 5%. Describe action the market maker could take to exploit an arbitrage opportunity and calculate the resulting profit. So here we have a forward contract. Observe it's like a 6-month forward contract, and we have the price of the stock after 6 months is 110. So let's compare these two numbers. We got the current stock price is 110. So the fair value of the forward contract is given by S0 e to the r minus delta t, and S0 is 110. So 110 times e to the 0.05 minus 0.02 half. This is the forward price, right? This is the forward price, and it is equal to 111.66. But the observed value is 112. This is the theoretical value, and 112 is the observed value. So and we say that the observed value is greater than the calculated value. So in order to exploit an arbitrary opportunity, we basically have to we buy low, sell high. So we have to sell the observed forward at 112 and then buy a synthetic forward at 111.66. We basically buy low, sell high, and we at the same time we make 0.34 profit. So basically at the same time we buy low, sell high. The low one is 111.66 and the high is 112. So we sell a observed forward contract to get 112, and we pay 111.66 to get our synthetic forward. So we still have a contract, and then we have 0.34 profits. Right, that's it for today. Thanks so much for watching. I hope you guys enjoyed my video. See you on the next video. Bye bye.